You are standing in a shallow ditch somewhere outside Aachen, Germany. The autumn of 1944. The air smells of cordite and wet leaves and something else, something metallic and sharp that you've stopped trying to name. Around you, the sounds of a firefight are fading. The Americans have pulled back, or what's left of them has. Your hands are shaking, not from fear, not exactly, but from the cold and from the effort of pressing yourself into the earth for the last 40 minutes, while rounds snapped overhead like breaking branches. Now it's quiet. You look to your left and you see it. An American rifle lying in the mud, abandoned. The wood stock is dark with rain. The steel barrel is still warm. You pick it up. It is heavier than your Carabiner 98. Longer. The receiver is a single, machined piece of metal. Clean lines, no exposed bolt handle above the stock. There is something elegant about it, even caked in mud. You've heard about this rifle. Every German infantryman in Western Europe has heard about it by now. The Americans call it the M1. The GIs call it the Garand. You've watched what it can do. You've listened to it. That rapid, rhythmic crack, crack, crack that sounds nothing like a bolt action. Nothing like your Kar 98K, where every shot requires a man to lift his hand, pull back, push forward, push down, before he can fire again. The Garand just keeps going. One trigger pull, one shot, another trigger pull, another shot, 8 times, without pause. You know, in the pit of your stomach, what that difference means in a close-in firefight. You've known it for months, but now the rifle is in your hands, and you are about to discover something that no amount of battlefield observation could have told you. You are about to discover that this rifle, the greatest battle implement ever devised, as General Patton himself would call it, is in your hands almost completely useless. If you want to understand why, you need to understand one small piece of metal, not the rifle itself, not the gas system, not the trigger group, not the ammunition, just a thin stamped U-shape of steel, roughly 4 inches long, that most soldiers didn't think about twice. The En-Bloc clip. Before we go any further, if you find this kind of deep dive into the mechanics of history worthwhile, consider subscribing. We dig into the details that the textbooks skip, the small things that change the big outcomes. Hit that button and stay with us. Now, let's go back to the beginning. You are standing in a government office in Springfield, Massachusetts, sometime in the early 1930s. The man across the table from you is John Cantius Garand, a Canadian-born engineer who has spent the last decade trying to solve a problem that nobody had solved yet. How do you give every infantryman the ability to fire rapidly, accurately, and reliably without making the rifle too complex to survive the mud and cold and abuse of a real battlefield? The bolt-action rifle had ruled infantry combat since the 19th century. It was simple, it was accurate, it was proven. The M1903 Springfield, the German Carabiner 98, the British Lee Enfield, all bolt actions, all designed around the same fundamental sequence. Fire, work the bolt manually, chamber a new round, fire again. A trained soldier could manage 12 aimed shots per minute, maybe 15 in ideal conditions. But ideal conditions don't exist in combat. They never did. The concept of a self-loading rifle, one that used the energy of firing to automatically chamber the next round, had been circling military circles for decades. John Garand had been working on his design since the early 1920s. His early prototypes used a primer-actuated mechanism and a detachable magazine. The Army told him no. The Army told him something very specific. They wanted an En-Bloc clip. This is a crucial detail. Garand didn't choose the En-Bloc system because he thought it was superior. He chose it because the United States Army Ordnance Department mandated it. A rival designer named John Pedersen had convinced military brass that the En-Bloc approach was more reliable in the field, that a detachable magazine could be lost, damaged, or muddied into uselessness. The argument was that if the clip fed the rifle and then was automatically ejected, soldiers couldn't accidentally misplace it. The ammunition itself would arrive preloaded in clips, ready to drop into the action. So Garand adapted his design, and the result was a clip unlike anything in the German or Japanese supply chain. You are crouching behind a hedgerow in Normandy. It is June 1944. The Americans to your right have been firing their Garands for 15 minutes. You've watched the sequence. A GI presses down on the bolt. The action locks open. He takes a small metal clip loaded with 8 rounds, presses it down into the receiver, and the bolt slams shut automatically, chambering the first round. The whole motion takes 2 to 3 seconds. Then he fires, and fires, and fires. 8 shots without working any bolt, without any manual cycling, without any pause, except the discipline to aim. When the 8th round fires, something happens that has become one of the most famous sounds of the Second World War: a metallic ping. The empty clip ejects from the receiver, spinning upward and away. For decades, people have whispered that this sound was a fatal flaw, that it revealed to the enemy that the rifle was empty. You've probably heard this story. The truth is that military researchers studied this question both during the war and after, and they found the myth almost entirely unsupported. In the chaos of sustained firefight, rifle reports, machine gun bursts, mortar impacts, shouting, the ping of an ejecting clip was nearly inaudible from any practical distance. And the 3 seconds it took to reload meant the window of vulnerability was almost non-existent. Some veterans even turned it into a tactic, deliberately ejecting clips into the brush to lure the enemy into exposing themselves. The ping was not the Garand's weakness. We'll come back to its actual weakness in a moment. You are back in that ditch outside Aachen. The Garand is in your hands. You know what you're doing with rifles. You've carried your Kar 98K for 3 years. You press the bolt handle, the action opens and locks back. You reach into your webbing, and here's the problem. You have .30-06 Springfield ammunition. You may have picked up some rounds from the American dead or from a supply cache. The Garand's caliber is not your caliber, but let's say you solved that problem. Let's say you have the right ammunition. What you don't have is the clip. The En-Bloc clip is not a standard German item. It never was. The German army had no equivalent in its supply chain. The Kar 98K used a simple 5-round stripper clip, a small piece of metal that helped press rounds into the fixed internal magazine, then was discarded. The rounds went into the rifle. The stripper clip was thrown away. A trained soldier could reload the Kar 98K with 5 loose rounds nearly as fast as with a stripper clip, if necessary. The ammunition existed independently of the loading device. The Garand was designed differently. The En-Bloc clip was not discarded. It was an integral part of the loading system. Without it, you could not quickly reload the rifle at all. You could, theoretically, press individual rounds into the open action one by one, but you'd be loading a semi-automatic precision instrument as though it were a muzzle loader. 1 round, work the bolt manually. Fire. 1 round, work the bolt. Fire. The rifle that could deliver 8 rounds in 8 seconds becomes a weapon that delivers 1 round every several seconds, and an unreliable one at that, because the gas-operated action wasn't designed to be cycled by hand. The rifle in your hands weighs 9.5 pounds. It is 43 inches long. It is, without its proprietary clip, a very heavy, very awkward, single-shot weapon. You set it back down in the mud. This wasn't an accident. It wasn't a flaw in the Garand's design. In fact, from the American perspective, it was almost a feature, not one that was designed intentionally to confound the enemy, but one that was a natural consequence of how deeply the En-Bloc system was integrated into the weapon's architecture. The clip was stamped from a single piece of steel, with spring fingers that held the 8 cartridges in a staggered formation. It locked into the magazine well of the rifle. The bolt and follower rode against it as rounds were stripped and chambered. The clip was such an intrinsic part of the feeding mechanism that removing it from the supply chain didn't merely inconvenience the rifle, it crippled it. The United States had solved this supply problem on their own end with elegant logistics. American .30-06 ammunition for the Garand was not shipped loose. It was factory-packed directly into En-Bloc clips, then loaded into bandoliers, 8 clips to a bandolier, 64 rounds ready to fire. When a GI ran low, he reached into his bandolier and pulled out another clip, still in its cardboard sleeve. The clip was the packaging and the feeding device simultaneously. For the Germans trying to use captured weapons, this created a closed loop they couldn't break into. Even when they had the ammunition, which was itself rare, they rarely had the clips. And without the clips, the rifle was nearly useless. You are walking through a German armory somewhere in France, late in 1944. A Wehrmacht ordnance officer is cataloging captured Allied weapons, a common practice for any army fighting a war. The Germans were competent at this. They evaluated captured weapons, assigned them German designation numbers, distributed some for use by rear echelon troops, stripped others for parts. The captured Garand presented a unique problem. Unlike a captured Bren gun, where British 303 could sometimes be scavenged or substituted, or a captured Thompson submachine gun, where the 45 ACP was at least a caliber the Germans understood and could source, the Garand required a specific loading device that existed nowhere in the German industrial or logistical ecosystem. There is a fascinating parallel with what happened on the other side of the world. The Japanese military encountered the same problem. After capturing M1 Garands in the Pacific, Japanese ordnance tried to adapt the rifle to fire the standard Japanese 7.7mm cartridge. They quickly discovered that the En-Bloc clip system was incompatible with their ammunition dimensions. Eventually, the project of rechambering captured Garands was abandoned entirely. The Japanese decided instead to reverse engineer the entire rifle, replacing the En-Bloc system with a 10-round fixed magazine fed by 2 standard 5-round stripper clips. This became the prototype Type 4 rifle. Of the parts manufactured, only around 125 were ever assembled into functional weapons, and the war ended before any entered service. The En-Bloc clip had stopped 2 industrial nations' worth of engineers in their tracks. You are back in Springfield, Massachusetts. The year is 1936. The rifle has just been officially designated the U.S. rifle, caliber .30 M1. John Garand is shaking hands with Army officers. He is not thinking about German soldiers in muddy ditches 8 years from now. He is thinking about whether the gas system will function reliably in the Philippine heat and the Alaskan cold. He is thinking about whether the action will cycle when it's fouled with Pacific beach sand. He is building a rifle for American soldiers. And the American logistics chain is designed, from the factory floor to the bandolier, to keep that rifle fed. By January 1940, Springfield Armory is producing 100 M1 rifles per day. By January 1942, that number has risen to 1,103 per day. At peak wartime production, Springfield Armory alone is turning out roughly 4,000 rifles daily. Winchester Repeating Arms is manufacturing them alongside Springfield. By the end of the war, the combined production of Springfield and Winchester will reach 4,802 rifles. 4 million rifles. Each one designed around a small stamped piece of steel that no other army on earth could replicate in the field. You are an American GI crossing the Siegfried Line in the autumn of 1944. You have been issued your M1 Garand at training, and you have been firing it for months. Your bandolier holds 8 clips, 64 rounds across your chest. More are in your pack. Your squad has 8 men. All 8 carry Garands. All 8 have clips. When your squad opens fire, the sound is not the rhythmic crack pause of bolt-action fire. It is a sustained, overlapping crescendo that the Germans on the other side of that line have come to fear and study and fail to match. German infantry doctrine was built magnificently around the machine gun. The squad existed to support the machine gun, the MG-42, the most terrifying automatic weapon of the war, capable of cyclic rates approaching 1,500 rounds per minute. Individual German riflemen with their Kar-98Ks were the supporting element. The machine gun was the killing element. American infantry doctrine worked differently. The M1 Garand meant that every man in the squad was himself a source of substantial automatic equivalent firepower. The machine gun supported the squad, not the other way around. A German soldier in a firefight with an American squad wasn't facing 8 bolt-action rifles. He was facing something that felt much closer to 8 machine guns. This is what Patton meant when he called it the greatest battle implement ever devised. Not that the rifle was the most accurate, not that it was the most powerful, but that it transformed the ordinary infantryman, not the specialist, not the machine gunner, into a source of sustained semi-automatic firepower at the individual level. No other major military on earth had standardized a semi-automatic rifle for general infantry issue. Not Germany, not Britain, not Japan. not the Soviet Union at the start of the war. The Garand's feeding system, that proprietary clip, was both its logistical backbone and its accidental defensive armor against battlefield capture. You are standing in that ditch outside Aachen again. Let's stay there for a moment. The American rifle is back in the mud. You've let it go. But you keep thinking about it. Not the specific rifle, but the idea of it. The idea of an army that could outfit every rifleman, every ordinary foot soldier, with a weapon that fires 8 rounds without pause. You think about what that costs, not just in money, but in industrial capacity, in raw material, in the organizational machinery required to stamp 4 million of those steel clips and load 64 million rounds into them and ship them across an ocean to men who will use them and drop them in the mud. You think about the factories, the workers, the ships, the supply chain so vast and so coherent that it arrives at this ditch in this autumn with exactly the right piece of steel for exactly this rifle. You pick up your Kar 98K, 5 rounds, bolt action, accurate, reliable, lighter than the American rifle by more than 2 pounds, a weapon that has served the German military for decades. You work the bolt, you chamber a round, you wait, somewhere in the distance you hear it, that distinctive rapid crack. Not one shot, not a pause, not another shot, but 8 shots, one after another, without stopping. Then a metallic sound, barely audible, almost a ping, and then 8 more shots. The En-Bloc clip was never supposed to be a secret weapon. It was a logistics solution to a supply problem, mandated by bureaucrats in a peacetime ordnance department who were worried about soldiers losing detachable magazines. It was a design concession, not a design triumph. John Garand himself had originally preferred a different approach. But in the physics of war, in the closed, brutal logic of supply chains and captured weapons and industrial capacity, it became something more. It became a closed ecosystem, a weapon that could not be fully exploited by anyone who didn't have access to the same factories, the same stamping machinery, the same bandoliers packed on American assembly lines. It is a strange kind of advantage. Not one that appears in any tactical manual, not one that generals briefed their subordinates on, but one that showed up, again and again, in the simple fact that German soldiers who picked up American rifles could not sustain them, and the Americans who carried them never had to stop. Today, M1 Garands sit in gun cabinets and museum cases across America. The ping of an empty clip is, for most people who know the rifle, a sound of nostalgia. The sound of a Saturday at the range, of a grandfather's war story, of a particular chapter in American history that is closing as the men who carried these rifles close their own eyes for the last time. The En-Bloc clip itself is a small thing, a piece of stamped steel. You can hold one in your palm. It weighs almost nothing. But somewhere outside Aachen in the autumn of 1944, a German soldier picked up an M1 Garand and set it back down in the mud because of exactly this object. That moment, unreported, undocumented, repeated thousands of times across the mud and snow of Western Europe, is where the En-Bloc clip stopped being a logistics solution and became something else entirely. A line in the ground that one army could cross and the other could not. Thank you for watching. If you're new here, this channel is dedicated to exactly these kinds of stories. The mechanics, the logistics, the small decisions that shaped the largest conflict in human history. Subscribe so you don't miss what's coming next.